Okay, please prepare. Thank you. If you guys are ready, please give a thumbs up again. Thank you.
Chicos, volvemos para dar inicio a la segunda parte del taller.
마이크 켜져 있어야지. 마이크 켜져. 어? Okay, we will continue the class. I think everyone is ready. Okay. So moving on, let's go to the data pre-processing. So after you guys imported the data, we need to see the data that what is in it and how many data are in it. So we're gonna display the basic information about the data sets using the info function that we have done it lots of times. So as you guys all know, this helps us understand the structure and the size of our data. So if you run this code cell, you can see like the information of the training data and the test data. So the training data consists of 90,999 entries with 785 columns, while the testing data contains 9,999 entries with 785 columns. So this kind of information, the information of the data, is crucial for verifying that our data has been loaded correctly and to identify the features and the label columns. So if you run this code, please give a thumbs up. Thank you.
Sorry, one question. So this data set contains images, right?
Actually, it is a CSV file, which is an Excel file. So, in this Excel file that we learned on Monday in your time, it contains the pixel race of the uh, uh, numbers of the handwritten data. So, which is called the MNIST data set. So, actually, it is all numbers, but we can say it is an image data also, but not like those like JPG or like GIF, those kind of real images, but kind of like numbered images. Yeah, that would be, yeah, for
Thank
your
you.
understanding. Thank you. Yeah, I'll just wait a little bit longer. Okay, moving on. And to prepare our data for the convolution neural network, we need to extract the features and the labels, which we learned as the data preprocessing. So this code extracts the feature columns and the label columns from both the training and the testing data sets. The pixel values of images are normalized by dividing by 255 to scale them between 0 and 1, which we learned on the second week, which called the normalization. And the data is then reshaped to include the channel dimension, and the labels are converted to one-hot encoding using the two-categorical function. So also run the cell, and if you guys are ready, please give us some. Thank you. So this is kind of a preparation to make the model to understand the data set. So not all MNIST data are all the same. So as we did before, we need to check if the data sets are what it is created with and how many labels are it. We need to check for it, and then we need to pre-process the data. Okay. Question to Lee. Okay, moving on. So this is the most important part of what we're gonna do today. So this code is the thing that we saw before. Yeah, this is the thing that we are gonna make. And if we change this picture into a code, then this happens. So you guys will see that I make a blank on under the build the CNN model, and I wrote the code. So you don't need to like code the libraries and also the compiling the model, but please code the CNN model that I make a red rectangle thing here. So please write the code down on the cell that I wrote. And if you guys are ready, and if you compile the model, please give a thumbs up also. Thank you. And if you guys have any problems or questions, please leave a chat or turn on the mic and say to me. a dropout prevents the overfitting. So, I don't recommend, but if you train the model without the dropout, then the accuracy will not go down from 100%, which I said is a overfitting. Yeah. So for that, we use the dropout method to make it not non-overfitting. Yeah. I never used like more than once, but yeah. In my experience, I only used once, so yeah. But 2 times? I don't know it will work, but maybe I should try about it. Yeah. Great, precious. I'll give you enough time for you guys because today's class is not that long. So please code freely. Thank you. Oh, wait. Much longer. Yeah. Okay, many people are done, so we're gonna move on. So here we define the CNN model using TensorFlow and Keras. So we start by importing the necessary models and building the model using the sequential API. The model consists of the two convolutional layers with ReLU activation, followed by the mask pooling layers, a flattering layer, and two fully connected dense layers with a drop-down layer in between to prevent overfitting. And the final layer uses a softmax activation to the output, the classification probabilities for the 10-digit classes. So this is the main code, and almost I could say that this is all for today. Yeah, because this is the main code. If you write this code, then that means that you make a convolution neural network. Yeah. So if you run this code, you will see a summary of the model. Before that, let's talk about a little bit of the codes. First, the sequential API creates a linear stack of the layers, and conv two-dimensional, which means the convolutional two-dimensional, as the 2D convolutional layers, and the mask pooling two-dimensional as the mask pooling layers, and flatten converts the two-dimensional feature maps into the one-dimensional vectors, and dense as fully connected layers, and dropout, like I said, as regulations to prevent overfitting. And under that, the model is compiled using the Adam optimizer and categorical cross-entropy loss function. So the learning rate from the optimizer is set to 0.001, compiling the model prepared for its training by configuring the learning process. So using the summary function provides a summary of the model architecture, displaying the layers, output shapes, and the number of the parameters. So talking about a little bit of the code, if you make the learning rate high, as you have learned, the model will be much more complex, which could lead to great output, but sometimes it could not work, or like it will take a very long time while training the model. So changing the learning rate is a very you need to have caution while changing the learning rate. You should not like change like big steps, you know. Although if you want, you can change, but sometimes it could lead to like very bad situations. Yeah. So using the summary function, you could see the summary of the CNN model that we made. So it provides details about each layer, like the convolution layer, pooling layer, or the dense dropout, those kind of things, including the type, output shape, and the number of the parameters. So this information helps us understand the structure of our model and the complexity in the terms of the number of the trainable parameters. So moving on to the next code. Now we made the model, we need to train the model. So we train the convolution neural network model using the fit function, specifying the training data that we have imported, the number of epochs, batch size, and the validation data. So the number of epochs defines how many times the model will iterate over an entire training data set. And batch size specifies the number of the samples per gradient update, and the validation data is used to evaluate the model's performance during training. So the more smaller the batch sizes get, the more the model needs time while training. And also the epoch, the more it gets bigger, the more time it gets. So I don't know how much time will you guys take, but if you run this code, the model will start to train the model. So please run the code, and if you guys are ready, please give a thumbs up. Thank you.
here. You want? Yeah, or no? Because I can hear you now. I don't know if you're mute.
Yeah, I can hear you. Yeah, sure.
Okay. It's to tell
Yeah.
you about I tried to put like two the out like one before the layers, but
Yes.
affect the currency a lot. It's
Oh.
because I read like in TensorFlow that you can put one before any layer that you have, but affect the currency. And the answer sometimes you can put one before the layer, sometimes it's only one in the final. It depends, but like don't specific the answer when you need to put like some or only one.
Only one. Okay. Thank you.
G1, one question. Is there any rule for epochs and batch size? Like what number you have to use? I know it depends.
Yeah.
Sometimes I don't know, which values I have to use, like 16, 8, 32. So if there's any recommendation for that.
Like there's no answer of this because it is just kind of a hard process that you need to find the best epoch and the best batch size by trying various epochs and also the batch size and also the learning rate. So I couldn't like for me, I just used the batch size as 32 and epochs were about like 10 averagely, but yeah, it depends on which data you use, which model do you use, and also which kind of output does it make. So there's like no answer that this is like 32 is the answer, but yeah, the only answer is that you just find the best accuracy one to by changing various parameters. Yeah.
Yeah, that makes sense. Thanks a lot.
Thank you. For someone, it could train fast, but for someone, it could train slow because it depends on the network. So don't worry. If you just wait, the model will train automatically. Okay, moving on. So, trying running the model, and we could see the training process output. So each epoch's progress is displayed on the cell. So including the loss and accuracy for both the training and validation dataset. The model's accuracy improves with each epoch, indicating that it is learning to recognize the digits effectively. So this output is crucial for monitoring the training process and making necessary adjustment. So after training, we need to evaluate the model's performance on the test data set. So this step provides the final accuracy and the loss metrics, helping us understand how well the model generalized the new unseen data. So the evaluation results are essential for determining the model's effectiveness in the real-world applications. So if you guys did the validation part, please give a thumbs up. Thank you. Okay, so if you run the code cell, you could see the result. And for me, the test accuracy is almost 98%, which is very good. So finally, you could visualize the prediction made by the model on test images. So this step help us the model's prediction and compare with the actual labels because we visualize the result. So visualization, as you guys all know, provides the tangible understanding of the model's performance and highlight any potential areas for improvement. And I don't know if you guys remember, but if we see like the graph like this, and which means it trained very well. If like there's like graph like going down or like up suddenly, then it means the overfitting and the underfitting. Yeah. So please run the cell, and if you guys are ready, also give a thumbs up. Thank you. So this is all for today. Actually, today's class is kind of short because it is kind of a makeup class for the Monday. And originally we wanted to do a hackathon with you guys, but we have a lack of time, so it was unable to do the hackathon. So sorry for that. And saying a little bit more about the CNN, I told you guys about the layers of the CNN and the basics of it, but this is not all. Like there could be more layers in the CNN and also more concepts in it. So if you guys are more interested in, and also if you guys want to know how does it work, for example, how does the ReLU function works, or like how does the dropout works, then kind of it moves from the programming to the mathematics, especially in linear algebra kind of thing. So if you want to go much deeper than this, then I recommend you study mathematics and also watch papers related to the CNN convolution neural network. And for other ones, if you guys, I don't know if you guys heard about like ResNet or like VGG19. These kind of things are called the pre-trained model, which like other very great professors made, already made the great image processing model, which is the CNN model. So if you guys like search for it, there's like libraries in TensorFlow, so you can use it easily. Those kind of pre-trained models, so it is already trained. So you just need to like import the model and you can use it. And these kind of models are made in like the paper, like those like professors wrote kind of things. So if you guys are more into it, I prefer you could use the pre-trained models and also study a little bit more about the mathematical things. And also, if you guys want to study more, I also prefer Coursera. Coursera is kind of a thing that you could watch the major universities such as like MIT, Stanford, or like Cambridge. You can see the real lectures of those universities. So for me, I watched the mathematicals for AI, which was a lecture for Stanford. So if you guys have a chance to study more, I prefer Coursera for you guys. So that's it all for today. Thank you for following my class. I hope you guys have a great day. Thank you.
Thank you, Iwan.
Thank you, everybody. Juanca, no sé si alguno tiene una pregunta. If somebody have some questions or something, I will ask for everybody here. ¿Alguno tiene alguna pregunta o alguna duda?
No, señor.
¿Todo bien? Okay, nobody have more question for today. Really thanks for another new class, another really nice class that you can offer now. We are so happy with this opportunity and 감사합니다 for everybody here today.
Thank you, gracias.
Have a great weekend.
Chicos, entonces nos vemos Dios primero el lunes, ¿verdad? En la próxima lección. Ya sería la última semana del taller. Entonces igual lunes a las 2 de la tarde vamos a estarles pasando el link en el transcurso de hoy o mañana. A más tardar mañana les pasaríamos el link de la clase. Y sería todo por hoy entonces. Muchas gracias.
Chicos, se les va a pasar también una lista con los nombres completos de ustedes para que verifiquen que estén bien escritos para la generación de los certificados, de que no vayamos a tener ningún error con el nombrecito. Entonces, para que estén pendientes del WhatsApp, pueden revisar de que el nombre de ustedes vaya correcto y completo, porfa. Que tengan feliz fin de semana. Nos vemos el lunes si Dios quiere.
Igualmente.
Igualmente. Muchas gracias. Buenas tardes.
Bye, thank you.
Thank you so much for everything. See you next week.
감사합니다.
Thank you. Bye.
Thank you,
See you
everybody.
Monday.
Bye.
Bye.
Gracias.
Un gusto.
Ya llevo casi la mitad de la revista, chicos, traducida. Me hizo falta poner